Mm. I have the record button covered by my phone. So it's great. Oh, I got a chat. Nita. Since homework past 3-6 hasn't been graded. Well, Athena, this might be true for you. I've been grading the shit out of chapter 4 and 5. I just haven't quite gotten to everybody's yet. We definitely are still taking the quiz. The whole point of, so the best world would be all the homework is graded. And that just wasn't going to happen. So I graded as much as I can. So there are people that got their 4 and 5 graded. But the point of the homework is to come ready with questions from the homework that don't make sense at that time. And the quiz I made doesn't really get too deep. So it's, yeah. Is that all right? Do you understand? So I know from an individual person's viewpoint, you can't see all the other stuff I've graded. So for a few people, I'm sorry, especially what really sucks is my last name is Waller. So for all the people out there that have last names that start towards the end of the alphabet, and you always got lined up at the end of the line, I'll never forget second grade. I was always at the end of the lunch line. All the good hot dogs were gone. Anyway, I'm still a little bitter about that. And here I am again, just perpetuating. I just go alphabetically. So if your last name is later in the alphabet, I very often don't quite get there. I will say this: I do try as best I can to grade the homework before the quiz. It just wasn't going to happen this weekend. But we are still going to take the quiz. It isn't very. I don't want to say it's not difficult because then somebody's going to think I'm making that shit up. But all right, so let me do this. I have a question. It's number 69 from section 5.2. And it is the one that talks about folding. Where'd you go? Dadgummit. Let me share it with you. An open box is to be constructed by cutting out square corners. You guys can see this one, 69? Yep, I'm going to take that as a yes.
Yes, we can see it.
Thank you. Yeah. Gather. Okay. Open box. So I've got, it starts off as 8 by 8. Okay. But then I cut out squares that are X by X. Sound like that's a square.
Who's sharing?
Sorry. Please speak up when I'm doing something silly like that. And let me do this. Let me spotlight myself. Okay. So it started off as 8 by 8, and then I cut the corners out. So it makes that shape there. Neat little thing. Because then I could fold and fold. If I fold this up and fold this up, doesn't that make like a little carry tray or something, right? Maybe something that works just as good as the carry tray in a theater. I love the people that eat dinner at a movie theater. I'm like, who the hell are you? Anyway. Let's pay $80 for hot dogs and nachos at the theater. Do you guys understand what's happening here? So, right? And then they want to know something about the volume. Let me go back to the book. Yeah, express the volume of the box as a function of X. So once you fold those up, it's going to look like something like this. See if I can do any better at all. No, I can't. I stuck. I'm so bad. Okay. Pretend like that's somebody sat on my box. So I'm sorry. How tall will this be? Once you fold these up, how tall will these be? How tall will the X? 11, exactly, right? And then you got to think, how long are these sides? So you got to think how much is left you. That's all I'm going to do. That should
Would it
be
be,
enough. Sorry?
sorry, do you want me, okay, never mind.
Good, thank you. Hold that thought. Hold that thought. That should be enough to get what you need because they're asking about the volume. And of course, the volume of something like this would be length times width times height. So the whole point is find these things in relation to x. Once you can find all those things, you multiply them together, you're done. Next. I love it. So that's a beautiful example of that kind of, because then the next thing I could do is say, find the maximum volume or something. That would actually be a calculus problem because it wouldn't be quadratic in x. It would be cubic. Yeah, okay. Any other questions? And as always, if you are too shy to speak up and you have a question, just privately chat it to me. No problem.
How about number 69 and 5.1?
All right, let me see. Ooh, yeah, okay. The neat thing about 69 is it's just like 66. They're the exact same problem. It's just that 69 says 6 and 66 says 200. But so what are your unknowns in number 69? What are your unknowns?
The pairs of numbers.
A pair of numbers. So give them names like we have to. Any unknowns we have to give them names. What would you name
3
them?
plus
Not like,
3.
stop it. So, I mean, this one should be really obvious, especially after the discussion we had about squares making the largest area. The answer, you know the answer. I don't care. I need to see the work. It's
Right.
the work that, so we already know what the answer is going to be. Oh, Brian, don't worry about it. You're fine. You're fine, man. I'll always I'll always correct things. So what names you're going to get? We have two numbers we don't know. So you're going to call them, it doesn't really matter. You can call them X and Y, A and B. You can call them Fred and Ethel. I don't care, right? And then those two things, what do they do? What do they do together?
The sum of them equals 6.
Yeah, if you, say again?
The sum of them equals 6.
What's that equation then? If we're going to call them X and Y.
X plus Y equals 6.
So that's what they tell me. That's what they tell me. X plus Y equals 6. What do they ask me?
They want
What's
to
the
know
product?
what the product
The
of the
largest product. And what's that? How do you write the product of those two?
X times Y.
X times Y, kick ass. So now you use what they tell you. You can solve for X or Y, plug it in what they ask you. That's all I'll say. It's the same. So I tell you, this might not be true, but what really helps me is to break it up into what do they tell me and what do they ask me. Because then I can focus everything about setting up what they tell me, and then I can focus everything about setting up what they ask me, and then I can step back and see how do they interact with you. How can I solve for a variable and plug it in the other one? It just helps you compartmentalize the problem. And the people that do that naturally are the ones that are really good at math naturally. Well, that's good for them. Some of us need some extra help. All right. I say us, and I was one of those jackasses that came to naturally, so oh well. But I can. I understand it, though. It definitely helped me out being able to pay attention to how to break things up, right? Anything else? Any other questions?
For 36 and I think it's, yeah, 5.1, it says find the intercepts. I forgot how to do that from just an equation.
Oh, yeah. So here's the beautiful, you ready? You ready? The last math course I took, I'm pretty sure it was Math 696. And I had an equation with 13 variables in it. So how did I solve for the W-intercept? I made all the other variables 0. So I don't care what level of math you're in. How do you find the whatever intercept? You make the other letters 0. So to find the y-intercept, I make x 0. That's going to be the easy one when it's a function of x, right? To find the x-intercept, I make f of
Y
x,
0.
which is y, exactly. I make the y 0, which very often is called f of x. I just make that whole thing 0. Don't plug a 0 in for x. Make the whole thing 0. So that's why to find the x-intercept, we very often try to factor because it's equal to 0, and that's how you solve a quadratic or something higher equal to 0. You try to factor it. Does that make sense?
Yeah.
So that's why first thing I do is factor when they're like asking me to find the x-intercept. That's why, because I know I'm going to set it equal to 0. If it's factored, I can just see the answers. What happens if factoring doesn't work? What's the thing you use if that doesn't work?
Quadratic formula.
Quadratic formula. Kick ass. I like it. I like it a lot. Be very careful. If I don't say, in fact, on my quizzes and stuff, I am very often very descriptive about what I want you to use. But in the homework, if they do not say use the shortcut, well, let me be more specific. Let me see, where can I find this? Was it 5.2 or 5.1? Here we go, yeah, 5.1. So these problems here, what I really want to see from you here, to rewrite it in standard form, I need to see the completing the square. When they say, so that's because that's the point of it, is to put it into standard form from which you can get the vertex. Are you guys with me? If I do the shortcut, it's kind of like cutting out the whole point of putting it in the standard form. Once you get to this section where it's all about determine the maximum value, then screw it. Use the freaking shortcut. That's the only thing I need from this problem, so just use the shortcut. Then that's fine. Does that make sense? Some of you guys that I graded those sections, you'll see me saying, they didn't say to use the shortcut here, so I really do want to see that completing the square thing.
So you just want us to use completing the square to find the vertex in that situation?
For those few first problems, just to get completing the square kind of some practice with it, because it is going to have it's going to have other uses later. So I need you to know it. All right. Anything else, guys? Oh, okay. I think I've got, well, shit. Well, I'm still missing like 8 people. That's not horrible, I guess. Okay. So let me talk about the quiz for a little bit. So we are having a quiz. It's not going to happen during class time. I'm giving you, let me kind of show you what it's going to look like. I'm giving you until tomorrow at 2, but once you open it, you have 1 hour and 20 minutes to do it. I'm almost certain some of you guys are used to that in other classes. Oh, shit. Sure. I mean, is that too much time? I'm sorry. Should I make it less time? All right. Let me show you, hold on. Let me show you 2 things. So you will find it eventually. No, Jeff, you know better. You'll find it in the quizzes part. If you go there right now, these don't show up yet for you because I don't have them showing up until at the end of class, right? But they will be right here. Now, this is where the quiz will be. Please understand this. Please understand this. This is where the quiz is going to be. This is where you turn it in. Because I could make you turn it in here, and then that sucks so bad for grading the shit. It drove me insane with this other class. It's so much easier for you and me if you submit it like a normal assignment. You scan it, and then you would submit it just like a normal assignment, right? All right. So let me show you a little preview of this thing. Don't get too excited. So you can see over here the timer. That'll stress you out, so you can hide that if you want to, right? You don't want to see that thing. And you can read through this. Once you click on take the quiz, blah, blah, blah. When you're done, click on the text box. So Oh shit. Okay, I wasn't supposed to do that. Hold on. I don't want to show you the quiz. Oh, that's the other thing. There. Why didn't you do that right now? You silly thing. All right. So here I am all the way at the bottom of the quiz. The quiz is up there. When you're done, click enter the time that you're submitting it, and then click submit quiz, and then go submit it. You guys understand? Because doing that will stop the timer, so it won't look like you're late. So you get an hour, 20 minutes. There's 6 questions. They're not in depth. They're not asking you to create a 3D image and then calculate the volume. No, right? It's not, don't freak out. It's nothing crazy. All right. So everybody get a feel for how this thing is going to work. So you have until, did I say in here? It will say it here. You have until September 15th, tomorrow at 2 p.m. So anywhere between the end of class and 2 p.m. tomorrow, find an hour and 20-minute block and do the quiz. If it turns out, if something happens and there's something, I can work with an individual person on something, but stay in touch with me if something goes wrong. You with me? Because the technical aspect of all this shit is the worst thing in the whole freaking world. I just want the math to be the problem, but in this world, I can't, it's not allowed. Everything else has to be the problem also. Okay, all right. There's something else I was gonna say. Dadgummit. I totally forgot. Okay, too bad. Any questions on the quiz, how it's gonna work? All right, okay. All right. And there's any more questions on homework before I get back into where we left off? Nothing? Okay. All right. Oops, shit. I don't know where that is. Okay, I'm gonna find it. So there's a section coming up called rational functions. It's section 5.6. But I could swear that I saw somewhere there was a problem that talked about, I don't know where it was. So let me know if you hit a problem that talks about asymptotes for division of polynomials. I might be dreaming that I saw that somewhere, but I just don't want you to have a homework question that's, we haven't talked about how to do it yet. Okay. So last time we were discussing synthetic division. There was something that came up. Oh yeah, that's right. Somebody was asking me a question about, who was asking that question about why might you want to use the same value again? Which question was that?
That was me. That was number 5 from 5.5.
Oh, 5.5. Okay, we're not quite there yet. I got you. We're basically there, but we're not quite really there. But I might as well talk about it. So 5.5, number 5. Okay, good. I like it. So if you'll give me a minute here, I'm going to create a problem real quick. This is always exciting. You guys having a good time out there? Oh, neat. I like, that's really cool. Let me see. Okay, that looks like it's it. Let me double check. You guys talk amongst yourselves. Yeah, cool. Okay. All right. So a little review of synthetic division, and I'm also going to illustrate an example of that question you were asking earlier from 5.5. So, yeah. I like this. Yeah, this is good. So can somebody answer me this? Would I try to use 3 to synthetically divide into that? Can somebody figure out why that's a silly thing to try to do?
Because 3 doesn't go.
Because you're gonna miss the first number.
I'm not sure what you mean, miss the first number. 3 doesn't go into, you had the right idea. Who was saying that?
Into 4. 3 doesn't go into 4.
Yeah, 3 doesn't go into 4. So if this thing does factor out, I know it's going to have to be a bunch of things where this number, this number, this number multiply to be 4. Cool, right? So of course I'm not going to use 3. 3, no. 3 is not going to work. So who's got a better idea?
1.
Yeah, we could try 1. I'm going to say 2, just because I got a point to make. All right, so how do I set this up? What do I put here?
1.
1, -3, and 4.
You got to put 0, right? And then
Why
4.
is there a 0 there? Because,
There's a missing
Oh,
term.
I'm missing X.
yeah, and watch, I really want that to make complete sense. If I write the number, if I didn't have any 0, and I wanted 9,007 divided by 2, I still, I need something to tell me I have no hundreds and no tens, right? So then I know that 7 is a 1. So I need something here to tell me I have no x's, so that I know this is in the ones place. Does that make sense? It's like ones, x's, x squares, x cubed place, just like a number with zeros in it. Just let that make unbelievable amounts of sense. So with long division, with synthetic division, you need to put placeholders in there. I like it. And then how does this work?
Move the 1 down.
Good.
Times it
Move
by
the,
2.
whatever this is goes down.
Multiply.
Good. 2 times 1 is 2.
-1.
Add. Multiply. Add. Multiply. Add. So what have I figured out so far? I have figured out that x cubed minus 3x squared plus 4 equals what times what? What have we figured out? What goes in this little dude?
X minus 2.
X minus 2. That's what correlates to 2. And then what goes in the bigger dude?
X squared minus x minus 2.
Kick ass. And there's no remainder. That's why there's nothing over something else, right? So I got x squared minus x minus 2. Now, right now, I would just factor this thing. But let's look at it. So watch, I'm going to screw this thing, right? This is old news. Screw that thing. I've got a much better form now of what's left. Let me try to divide it by 2 again. Why does that make sense? Give me 2 reasons why trying to divide by 2 makes sense again. Give me 1 reason. Like, all right. Could I have tried to divide this by 4? Would that have been a valid thing to try? Yes, because 4 goes into 4, right? Would 4 still be a good thing to try? No, because that doesn't divide by 4 evenly, right? But 2 goes into this still, but then some people say, but 2 already worked. I don't care. It might be multiplicity 2, right? It might work twice. And of course, I created this to do that. That was my whole point. So if you do this, and see how I can just stack them? Does that make sense? Take the answer from 1 and just keep going. So bring the 1 down, multiply, add. You could do it, Jeff. There you go, buddy. Multiply, add, bam. So now I get this worked twice, and I'm left with x plus 1. Bam. I like it. I like it. So let me give you guys one to try. This is always exciting. I could have done this before, huh? Not too bad for you. I'm not that good of a teacher. Let's see. Oh, this will be exciting if I did something wrong. Let's see. That'll be fun for you guys, huh? Ooh, wait a minute. Oh yeah, duh, me, I'm smart. All right. Ooh, neato, I like that one. That kicks ass. Okay, so do everything we just did. 2 might not work, 2 won't. Well, 2 might work. Do everything we just did, but do it for this. Where do you go? There you go. Jeff, you can do it, buddy. There you go. All right, now you're not missing any terms, so you don't have to worry about the 0. Can somebody tell me, just tell me a few good choices for what goes in the penalty box? What's a few good choices?
3.
3,
2.
2,
6.
6,
9.
9, 18.
1.
And by the way, plus or minus all of those, right? Right? Don't look at me like that. Yes. All right. So something you're gonna have to get used to is the first thing you try might not work. So what? It could be part of the process. In fact, this is really important. Listen, guys. We're gonna hit a lot of things in this class where part of the process, part of doing it correctly means doing something that doesn't work at first. That is part of the process. And I've seen so many people get, like they feel they're doing something wrong because they keep getting their first thing they try is wrong. And I'm like, that is part of the process. So this is a possibility. You could keep choosing something that doesn't work. You got to keep going. Thankfully, this is not a very long list. And it's probably not 18. I would hazard a guess. So if you find one that works, just type in the chat, I found one. Don't say what it is. I love it. Somebody's going to troll it. I found all of them. I'm done. Where's that? No. Probably was. Yeah, it was. Oh, I'm being silly. Okay, thank God. Okay. Oh, somebody found one. You could privately chat what worked for you. Interesting. Yeah. Yeah, exactly. So if you're having trouble, if anybody's having trouble, I'll tell you something that works. Several people have found this. -3 works. Emily, you're right. So try -3. And make sure, ask me questions now. if anything about synthetic division doesn't make sense, because this is going to become crazy useful to us very soon, like today. So you have to let me know if it's something about it's not making sense. So let me see. Drop that down, multiply, add, multiply, add, multiply, add. And then guess what? -3 works again.
What?
Dropped it down, multiply, add, multiply, add. So each one of these gives me a factor of what?
X plus 3.
X plus 3. So I got 2 of those. And then I was left with
X minus 2.
X minus 2. I didn't know that's X because it was cubed, that's squared, that's a single X. Bam. I like it. Somebody, is everybody cool with that? Any questions from that? So can somebody share with me a number you tried that didn't work?
I tried +3 first and it didn't work.
All right, so let's
Yeah.
take a look. There's still something interesting we can get from this. You ready? This is going to kick so much ass. There's still something good from this result. So let's all catch up to them. Oh, that's good. This is not working. Okay. So if we do this real quick, drop it, multiply, drop it down, and right here you're like, what the shit, right? Add, oh, that's great. Oh shit, multiply by 3, what is that, 54? And then that's 36. Is that right? Is that what you guys got? Okay, now stay with me, stay with me. For the purposes of what we're trying to do, this means nothing. Because we're trying to factor it, and that's why I need the remainder to be 0, so that it actually is a number, an expression that goes in evenly. But take a minute. Let me call this g of x. What is g of 3? Somebody figure out, take a minute, what is g of 3?
$36.
Holy shit. Why? What's amazing about that?
Because it's the remaining.
Is it just a coincidence? No, kids. Let me show you why this gets its own theorem. This is called the remainder theorem. And here is why this works. What does this result that we got really mean? That means that this, now stay with me, this is kind of freaky, equals x minus 3 times x squared plus 7x plus 18 plus 36 over x minus 3. Right? Is that cool, right? That's what we're doing with synthetic, right? You guys with me?
Yeah.
Yeah, okay. Now watch. Now let me go one step further than you would even consider being worth anything. And I've got no room to do it in. This is so beautiful, Jeff. Watch this. I'm going to multiply this by this. And then what do I get when I multiply this times this? So I'm distributing it to all these. There it is, right? Is that cool? And then I'm going to distribute it to this. What happens here?
Cancel out.
Cancels out. So you just get plus 36. So that is g of x. Are you with me? That's what our result tells us is a way to rewrite g of x is like this. And what do you get when you plug a 3 in? This whole thing goes to
0.
and you're just left with the remainder. So if I did put a 2 here, it would tell me what I would get if I put a 2 in the whole thing. If I put a 7 here, this would tell me what I get if I put a 7 in there. You guys, and this is actually faster than actually doing all the work up here, especially when you get really used to this. So this remainder theorem is kind of nifty. Even if you don't agree, it still is. Okay. So again, just to remind you guys, I do have that handout about synthetic division and long division up on the Canvas sites in case you want kind of a reference to remind you all the steps as you get used to it. All right, let me see. Blah, 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 blah.
So just to clarify stuff, you would have to find all the factors of 18, and then just it's either going to be plus or minus, correct?
That's right. And then you start using them. So one thing we're going to do when this starts becoming our basis, our thing that we have to each be able to do. And can you imagine if that number becomes 60 or something? And then it could be 2, 3, 4, 5, 6, 10, 12, 15. Holy shit. I mean, can you imagine that? And eventually we're going to get to the point where there are fractional possibilities. So that's going to increase. So part of what we're going to learn is theorems and methods to determine if any of those can be forgotten, if any of those can be thrown out, and whittle our list down. That seems like a very useful toolkit to have, a couple of things to make that list smaller. So that's why we are going to focus on some ideas about doing that. All right. And they take forever talking about the same thing. This is kind of crazy. Here we go. Perfect. Oh, here it is. It's here already, kids. We're already, since we divided by -3 twice, is something bigger we could have. Oh, all right, so we got to be really careful. I have to be careful how I say this. We did not divide by -3. Are you guys understanding? I say that because I am used to saying that and I know what I mean, but you're right, I have to be careful because we never divided anything by -3. What did we divide by? I know I erased it, but, oh, there it is. And when I had a -3, or what did that mean? We divided by what? Well, even this, I divided by x minus 3, right? So when I had a -3 here, that means I was dividing this by x plus 3. So somebody's asking me if I could divide by -3 twice, could I have divided it by something else, like maybe 9, I guess, but no, not really, because it would have meant this. And what is it about? Does somebody remember synthetic division can only handle directly dividing by what? What could be on the bottom of a problem? Like, can synthetic division directly take care of this problem?
Yes.
Yes. Can it directly take care of this problem?
No.
No. But now I really want you to see what, so this sort of ties into your question, private chatting person. But now we see I can just divide by this twice. So that's one workaround. If the bottom is factorable, if I'm trying to use this, I can still use synthetic if I can factor this into 2 parts that are x plus or minus number. Yes, no?
Do they have to be the same? Like,
No,
so for,
no.
okay.
Yeah, so it could be whatever in it factors to be x plus 4, x minus 1. That'll mean divide by -4 and divide by 1, which means put those numbers in the penalty box. But we understand we're not dividing by numbers, we're dividing by expressions, right? All right, so we all have to understand in the context of this problem, if I say divide by 3, that really means divide by x minus 3. I'm just thinking about what we're going to put in the penalty box. It just makes it quicker to talk about. Okay, I like it. I like it. And just to really make you guys trip balls. Yeah. What about if I had this? Could I use synthetic division? Yes.
Yes.
Yes. How do you factor this? Part of me wants you guys to say you can't factor that shit,
X
Jeff.
plus 3, X minus 3.
No, because it's not a minus.
Oh,
So what covers our ass in that case?
Plus 3i minus 3i.
There you go. And you can synthetically divide by a complex number. That is the most we'll do with that, is listen to me say that we can do it. Does everybody understand? You're not going to have to do that, right? The most we'll do with it is listen to Jeff and go, okay, Jeff. But you totally could, and it would work sometimes, because this could be a factor of something. I want to do an example of that, but I have to say no, Jeff, because you're not going to have to do that, so that's just a waste of time. Not yet.
that's like
Later.
Calc 2, huh?
What?
That's like Calc 1 or Calc 2 stuff.
No, it really isn't, to be honest, but we're not going to work with complex numbers directly for a little bit. Okay, so here's the next kind of thing. This is basically what I was talking about a minute ago. So let me ask you, here, let's do a really simple example. Let's see if I can make a problem. Now watch how I create this problem. This might be informative. If I can get it right in my own head, that would be great. I think that'll work. Yeah, okay. Take a minute and just factor that, right? Nothing, just factor it. Just factor it. Man, I really hope I'm thinking about that right in my brain. -20. Yeah, it looks like it works. Yep. I don't know what method you guys use. Here's the kind of like the full method. You do 2 times -10, -20. You get numbers that multiply, but that had to be the middle, right? You guys with me?
Yeah.
Yeah.
Cool. Yeah, 2 people. All right. It's pretty good. And then you can, now there's other ways to do this. In fact, as we're doing this, let me show you something. All right, let me see what you guys think about this. So that'll work. I mean, I'll break the middle term up, I'll group, I'll do all that shit. Let me show you something. The way that I sometimes do this, and if you don't like it, you never have to use this, right? But I just want to show you guys this. So the way I would do it is not just multiply that, but actually move that shit. And then factor this. Now stay with me. That does not mean the answer is going to be this, because I got to somehow move that shit back. So this will be -5 + 4, right? So how much, I shifted a factor of 2 to the end, so I got to shift a factor of 2 back to the beginning somewhere. So do you see how, stay with me. If you don't like this, you never have to do it. But if you sort of see what I'm talking about, you should try to do some of this yourself. Do you see how that makes 4x? Wouldn't it still make 4x if I made that a 2x and that a 2? Doesn't that still make 4x? Right? And didn't I just shift a factor of 2 back, like I factored it 2 there, and then I factored back, and that's the answer. And then you don't have to do all the grouping shit, right? Now that I am fine with, because you are connected to every step of that. The shit where you divide this by something or whatever, that's crap. That's magic to you. I don't like that. Anyway, so this will go to here. So what are the roots of this? What are the x-intercepts?
-2, 0, and then 5/2.
I like it. And I like that you're writing them as points if they were intercept. So yeah, let me just say, what are these equal to? These would be the intercept values for x. I like it. So what does that mean should work if I synthetically divide this? Shouldn't 5/2 work? Try it. Go ahead. It has to work. We know it's going to work.
Oh my God, it really works.
So bring that down, multiply, that's 5, add, multiply, that's 2 times 5 is 10, add, it works, but now watch. What's the difference between how this one, now how do I write what's related to this? Just directly, like this, that's it. And then this will be, what's this?
2x plus 4.
2x plus 4. So you see if I brought that extra factor of 2 in here, it matches with this? Yes? Okay, I like it. Absorb that for a minute. So when are fractional roots possible to consider for this when the first number is not just 1? All right, right. So that's the first level, is to show you where fractional roots become possible. And we already know we get freaking 5. This is not a big deal. This is nothing new, but we got to realize, oh, this connects to what the shit we're doing right now. So the next question is, okay, Jeff, great. How do I create the list of all the possibilities? 5/2 just happens to be the fraction that worked. What were all the possible fractions that could have worked for this? Right? Okay, so let's talk about that next. Does anybody still need this? Anybody? So list all the factors of that one. I'll get it started, plus or minus. You go. I'm sorry, little pin. You did good stuff. Oh, here we go. You were great. You were fantastic. All right. Plus or minus, give me the numbers for this. What are they? What works?
1, 2, and 5, and 10.
1, 2, and 5. And then over that, put the things that work for this. Why did this not show up until now? Because it would have always been a 1, and that just makes 1/1, 2/1, who cares? So now what I do now, to get the complete list of all the possible fractions that work, I do all the ratios. So I obviously get 1, 2, 5, but now I also get 1/2. 2/2 is 1 already, and 5/2. So that would be the complete list of possible rational zeros. I always put my extra E on there just because it reminds me of Dan Quayle and potatoes. I don't know if you guys will probably chew gum for that. Ooh, I like it. All right, that works. All right, so just take a minute and list all the possible rational roots of these. What do you got, Jeff? Oh yeah, sure. Why not go big? Sure. So list all the possible. It's like my 18th puberty right there. All the possible rational roots. I'll sit over here. And I don't know if anybody is wondering why I put like these on top. It's because remember when we had this, the answer was 5/2. This over that, right? It's always the end over the beginning. All right. Let's try to start catching up to you. What'd you guys get for this one? What can you write down? Plus or minus? What goes on the top?
1 and 2.
1 and 2. What goes on the bottom?
1, 2, and 4.
And?
8.
8.
I remember if I did that earlier. I forgot 10 up here, didn't I? Oh, shit. Oh, well. It's always its own self, right? Because 1 goes with itself. So if I got 1, I got to have 8. So now when you put this together, I get 1, 2 over 1. Then I get, let's see, 2/2 is already there. I'm sorry, let's start with 1/1 is already there. 1/2. What else you guys got? Keep going.
1/4.
1/4, I like it.
1/8.
1/8. Now go to 2. 2/1 is there. 2/2 is there. 2/4 is there. And 2/8 is there. So those are nice numbers, obviously, 2 and 8, because they go into each other. So you've got a lot of repeats. So the list is not nearly as long as it could have been. So what about this one? What'll go on the top?
1, 2,
1,
3, 4.
1, 2,
3,
3,
3,
4.
4,
6, and
6.
12.
12. I like it. This is supposed to be commas. Poor little dudes. And on the bottom, I put
1, 3.
1 and 3. Can you guys see this right? I'm not sharing, am I? Good. Thank God. So then I get 1, 2, 3, 4. I get all that 1, 2, 3, 4, 6, 12 because it's over 1. And then I get 1/3, 2/3. This is all plus or minus. 1/3, 2/3, 3/3 I got, 4/3, 6/3 I got, 12/3 I got. So thank God that some of these things in the list might be repeated. So your list is not as big as it could have been. Thank the gods. All right, I like it. So the last thing I think we'll talk about is some way to decrease the number of things I have to consider. Let me see where they give this. Oh, gross. Do they even give you? Oh, yeah, they give you this one. Who cares about this one? Well, okay, we'll talk about this one. All right. So let me see. Did I waste enough time? Is everybody finished copying? As if you could see what I wrote over there anyway. I'm sorry. All right. What is does anyone know the fella who we name the XY plane, the official name for the XY plane after? Does anyone know the name of the guy? What's the official name of the XY plane? Let's start there. Anybody know that?
Is it the coordinate plane?
No. So this has the name of a person in it. And it does start with a C, though. Does anyone know?
Cartesian coordinate plane.
Cartesian. So there was a guy, Rene Descartes. Rene, screw it, I'm not going to put his first name there. So the urban legend that you'll never see a movie made out of was that he was sick in bed and he was watching a fly on his ceiling and he was imagining how to tell where the fly was using a grid. And that's how he developed the Cartesian coordinate system. Was it true? I have no idea. Does it matter either way? Not really, right? In fact, most of the stuff that we use in math was created by people who were high on something or other, right? Doesn't mean that it's no good. It just, makes for an interesting backstory that you guys don't hear often enough. There were people that poisoned other people. There were duels. There was insane things that happened to claim ownership over some theorem or some process. It's actually a really cool history sometimes. And of course, sometimes it's also remarkably boring. But he's got an interesting thing about how to tell how many positive and negative real roots there are for a given polynomial function. So let's say I have a function, let's say 4x cubed minus 2x squared minus x plus 2. How many times, now this is going to be a little strange, but how many times does the sign change as I move from term to term? So this term is positive. Does the sign change here? Yes. You guys with me? Does the sign change from here to here?
Nope.
No. So I got one change here. Does the sign change here? Yes. So I got 2 total changes. So what this means, and the proof is it's going to take a little bit of time, but what this means is that there are either 2 or 0 positive real roots. So if that number would have been 3, I would have said there's 3 or 1 positive real roots. If that number would have been 1, then I'm guaranteed to have 1 real root. So the general idea is you start at what you get and then you go down by 2 until you get to 0. You can't go below 0.
Wait, before you explain this, sorry, can you explain again how you got the first 2?
What do you mean the first 2?
Like how you got that there are either 2 or 0. How did you get that again?
Oh, all right. So the proof of this is going to come. But right now, it's just because there is 1, 2 changes in sign. That's
okay,
it.
got it.
All right, that's the idea. So now, what about negative real roots? Well, to do that, I do the same thing, but I'm going to look at this function instead. I'm going to put negative x in there. What do I get when I put a negative x in place? Does this sign change because it's cubed?
Yes.
Yes. So it's negative 4x cubed. Does this sign change? No. Because the negative squared just stays negative. Becomes positive. So this stays negative. Will this change? Yes, because negative x is plus x. And of course, 2 don't give a shit. How many changes in sign do I see now? Nope. Yes. No. So that means that there is 1 negative real 0. And to kind of get a feel for why this is true, how many real zeros does this have? you guys see that? I don't know how far away I am from you.
There's only one.
One.
Yeah, there's one. And what is it? Is it positive or negative?
It's negative.
Yeah, there's one negative real root. And real quick, are there any changes in sign the way it is right now? Are there any changes in sign? No.
No.
What happens if I look at f of negative x? Then that'll be negative x plus 1. Is there a change in sign? Yes, one negative real root. And of course, if it makes sense for a single one of these dudes, it makes sense for a bunch of them packed together. And that's sort of how you build up to this. So if I did something like, if I took this guy, let's see, Jeff, let's make a nice one. Yeah, I like it. So what is the, make that a little F. What does the rule say about this? I see one change in sign the way it is. So there should be one positive real root. And if I look at the negative x of this, I see one change in sign again. So there should be one negative real root. And of course, if I factor this bad boy, I do get x minus 5x plus 1. So I will get one positive and one negative real root. So you kind of follow that as you build higher and higher degrees, and you get this general idea. Oh, somebody's asking me about why did this sign not change? Well, why did this sign change? I'm not doing negative times the whole thing. I am doing plug a negative x in. So negative x cubed is negative x cubed, right? Negative, it's still negative. So that's why this became a negative. What's negative x squared?
It's just positive x squared.
And negative stays negative. But then here, when I put a negative x in there, it becomes positive x and so forth. Is that cool? So the real shortcut for doing this kind of thing is all the odd powers change sign, all the even powers stay the same sign. All right, maybe. So how does this really help? This one's the weakest. I will tell you this right now. This is the weakest help. But it is kind of nice when I see this, because then I'm guaranteed to have one negative real zero. So maybe I'll go through my whole negative list. And thankfully, this in conjunction with some other things we can look at will really decrease the amount of stuff you have to look at. In fact, I'm going to take this away here in case anybody had a question still. What's really nice about the possibilities with this guy here just looking at it through Descartes' viewpoint, what's really nice about this guy? How many positive real roots will I have?
0.
Yeah, there's no changes in sign. So when I make my list, I can just eliminate that. I cut my list in half. That is when Descartes' rule of signs, which is what it's called, because we're very creative. Descartes did it, and it's a rule about signs. It's like it names itself. When I make my list, it immediately gets cut in half. How often does this happen? Not very, too bad. But when it does happen, I've just eliminated half of my workload. So Descartes, most of the time, doesn't really help us out that much, but when it does work, it does a lot. So you can take that as you will, I guess. Let me see, what time do I have? All right, good. See if I can, okay, good. I can fit in here. Yeah, so here, let me just show you how they kind of summarize. So this is page, oh, who knows? I guess I don't really have a page number here. This is section 5.5. They kind of summarize either equal to or is less than the number sign by an even integer. So you keep going down by 2. So if I saw 5 changes in sign in a given polynomial function, how many positive real zeros? 5 or 3 or 1? And whenever that happens, it kind of sucks because then you can't, oh well, it doesn't really give you a lot of information. That's what I mean. But for example, if you got 5 or 3 or 1 and 2 real roots worked for positive, 2 positive real zeros came out, there's at least 1 more. So you might as well try more of those. I mean, so it sort of helps, but not like a ton. All right. And then they give some examples, blah, 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 blah. So here, real quick. Well, let's see. Let's do this, because then I can bring up the graphing calculator too. Take a minute and figure out how many positive real zeros and negative real zeros for this. And then I think after this, we'll call it a day. So if you want to start that quiz tonight, you can do it. Let me see if I can do this. I don't know what you guys can see right now. Where is my calculator? There you are. Calculator. There we go. All right, so this is one of those situations where you get it or you do not. Somebody should already have the number of positive real zeros possible here.
4, 2, and 0.
Yeah, good. 4 or 2 or 0. Kick ass. And then the number of negative real zeros. This one's kind of nice.
It's 0.
Good. And I can see that just looking at this, because only the odd roots are going to change sign. I really hope you understand that, because they're the only ones that'll have an extra negative left over. So then everything becomes positive. So there are no negative real roots. So let's try to, if I do this, what do you guys see now? Do you still see the book? All right, give me a second. So it doesn't work as well as I hoped. All right, here we go. So now you should see my calculator, right? My infinite battery calculator. All right. So let me put the book over here so I can put the function in. So everybody, if you want to try this, let's go ahead and put that function in here. Let's see, 2x to the 4th is 10x cubed plus 11x squared minus 15x plus 12. All right. I can't see you guys anymore. There you are. So let's see. Now, if I just hit graph, I'm probably not going to get much of anything, but let's see what I get. Oh yeah, my window is set extra funkadelic. So let me do the zoom fit thing, just to kind of try to see where the calculator tries to start me off. Yeah. I don't know how much I like that. I kind of want to step out. Where am I? Okay, this is what I thought. So let's go to -5, 5. And what's my y? Okay, sure. -5. Sure, 60. Let's see what happens there. All right. Hey, there. See, now that's better. So that fit thing really doesn't do as well as it should, but it does give you kind of like a base to start playing around with the range. That looks more like what I expect. It looks like a weird piano. So let me go out further. I'm going to guess that this should kind of go down. Where am I at right now? Y min is -5. So let's go down. Let's take that down to -20. I don't know how comfortable you guys are with playing with the window, but all right, so now I'm closer. So let's make that -40 just to, let's see if that does it. I almost can see it. It's okay, Jeff. You don't have to. I want to see the damn thing. -50. Do what I want you to, graph. All right, there's the whole back of the piano. All right. So how many real roots do you see there?
2.
2. And those are what kind? Those are positive real roots. So we had 4 or 2 or 0 positive real roots. What do you think the multiplicity is on this one here? This could be a little bit of a strange question. I don't know how much you saw. This one definitely looks linear through this, right? You see how that looks like a straight line through there? This one looks like it might be a bit of a cubish shape through there. So this might be a multiplicity of 3 there. And that would make 4 total. But I want you to really understand. All right. Is everybody cool with what's happening here? Okay, let me make this one last point, and then that'll really be it. If I determine that there could be 4 or 2 or 0 positive real roots and no negative real roots, and they only find 2 positive real roots, what happened to the other 2? What the hell are they? I keep using a certain word. It's not inconceivable. Conceivable. Real. I keep saying real. So what would the other 2 be?
Imaginary.
Imaginary. Complex. Those little ornery things. Gosh darn it. Sorry. The only good complex varmint is a dead complex. All right, sorry. Little Caddyshack. All right. I think that's enough. That's a good place to stop. I don't want to. I'm obviously getting loopy. So we just did 5, 5, basically. That's where Descartes' stuff is. And I believe it's the next section that definitely gets deeper into, if they don't, to be honest, I don't remember if this one does it. There is something I might show you if this book doesn't get into it to help you limit your list of things. So I'll have to look to see if they actually do that. And if not, I'll make a little handout and it'll be something you'll be able to use to make things easier. But all right, so I think, was anybody not here earlier when I talked about how the quiz is going to work? Does everybody understand how the quiz is going to work? All right, I'm not getting any no's.
One
Is
question
there-
I was
Yeah.
just going to ask, when did you want us to finish it by? What was the due date?
Tomorrow at 2 p.m.
Got it.
And just let me know if something happens, you're called into work for an 18-hour shift or something insane, just let me know. Yeah, and just to show you, just to make sure everybody really understands this, in 2 minutes, this will be available to you. See how it starts at 6:45? So if you went to modules, it's still going to be in the quizzes module, right? You'll see quiz 3 right here. It will show up in approximately a minute and so many seconds. You'll see this. And then this will show up. This is where you submit it. So once you get it done, you'll type, I'm submitting it at blah, and then hit submit quiz here. But then you turn it in here. That will make, because what it is if you submit it, if I let you submit it here, you can't see what I write on it, and I have to download the shit and then upload it again. Screw that. So if you put it in here, then it's just like homework. You can see immediately what I wrote. I can see immediately what you turned in. So that's the lesson I've learned. So hopefully that doesn't confuse anybody. So if anything weird happens, just email me. And if you're running out of time and you haven't heard back from me, just email me the quiz. Do you hear me? And then eventually I'll figure it out so you can submit it, and I'll have a timestamp on when you emailed it to me so that it'll still be within the time. Does everybody understand? Okay.
I do
All
have one question regarding the quiz. I know at the bottom you want us to type, is it the remaining time?
No,
That is
just
left for the
type
quiz?
the time you're turning it in. So
Just the
if you're
time
done at
turning it in. Okay.
147, type turning it in at 147.
Okay.
It really doesn't matter what you type, but I just figured I'd make it something like that because that just tells me when officially the time stopped. Because when you hit submit after that, yeah. So it doesn't look like you went over time or something. Okay. Whew. All right, guys. Let me know if you have any questions, and otherwise you're free to leave.
Thank you.
Thank you.
Right. We write the timestamp on in the comments, correct?
I'm sorry, say again?
We write the timestamp on the comments, correct? Is that what you were
No, there's
talking
going
about?
to be, in fact, I put it in the quiz instructions. There's going to be a quiz box. I'm sorry, a text box at the bottom of the quiz. You type it in there.
Okay, makes sense.
Does that make sense? So it's sort of like something, I made it an essay question. So it's supposed to be for like an English class where I give you an essay question and you type it in. But it was just a way for me to make sure that you guys stopped the quiz when you were done. I don't know if that makes sense. I'm still learning this shit myself, so we'll see how it goes.
All right, thank you.
The rest of you guys okay out there? Brian, you okay? All right, I'm headed out. I don't know if you're there, but I'm gone now. Bye.